Welcome to CSIR JRF Net Physics class, quantum mechanics. This is the series number set 1, that is Q1 Photoelectric effect from quantum mechanics, CSIR JRF Net Physics. First question, which photon is more energetic, a red photon or a violet photon? Answer A, both. B, red. C, violet. D, neither. ഏത് ഫോട്ടോണിലാണ് എനർജി കൂടുതൽ? ഒന്ന് വയലറ്റ് ഫോട്ടോൺ, മറ്റേ റെഡ് ഫോട്ടോൺ. അപ്പോൾ ആൻസർ വയലറ്റ് ഫോട്ടോൺ ആണ് എന്ന് ഓർക്കുക. അതിൻ്റെ കാരണം ഇതാണ്. Violet photon has more energy because the energy of photon is given as E is h nu, where E is energy, h is Planck's constant, and nu frequency. Since energy is directly proportional to frequency, you correct it as frequency, not wavelength. That is nu violet. You write as nu violet. Nu violet gets a nu red. The violet photon is more energetic than red photon. The correction is given in the bottom in red ink. Frequency, not wavelength. Energy proportional to frequency. Number 2, if the wavelength of electromagnetic radiation is doubled, what will happen to the energy of photons? Remain same, be doubled, C halved, D infinite. ഒരു ഫോട്ടോണിൻ്റെ ഒരു ഇലക്ട്രോമാഗ്നറ്റിക് റേഡിയേഷൻ്റെ ഫോട്ടോണിൻ്റെ വേവ്ലെങ്ത് ഡബിൾ ആക്കിയാൽ എന്ത് സംഭവിക്കും ഫോട്ടോണിൻ്റെ എനർജിക്ക്? ഉത്തരം ഹാവ്ഡ് ആണ്. ആൻസർ സി. യു സി ദി ആൻസർ. Explanation. Energy of photon is given as is h nu c by lambda. The energy of the photon reduces to 1/2 when the wavelength of radiation is doubled. ലാംഡ വരുന്നത് താഴെയാണ് ഇക്വേഷൻ്റെ. അപ്പോൾ ലാംഡ ഡബിൾ ആക്കിയാൽ എനർജി പകുതിയാവും, ഹാഫ് ആവും. Number 3, what happens to the wavelength of a photon after it collides with an electron? What happens to the wavelength of a photon after it collides with an electron? A increases, B decreases, C remains the same, D infinite. Answer A, increases. Wavelength. A photon transfers a part of energy to the colliding electron, so its energy decreases, and consequently wavelength increases because E is hc by lambda. Since energy decreases, wavelength increases. This is because the energy of the photon is inversely proportional to wavelength. That is the equation. E is hc by lambda. E inversely proportional to lambda. Next question. Why are alkali metals most suited as photosensitive metals? Why are alkali metals most suited as photosensitive metals or materials? A, high frequency, B, zero rest mass, C, high work function, D, low work function. The answer is D, low work function. Low work function. You know, work function is energy required to, energy of the photon required to just liberate all electron from the metal barrier. So alkali metals have a low work function. Even visible radiation can eject out electrons from them. So alkali metals are the most suitable photosensitive metals. Next question. Which radiations will be most effective for the emission of electrons from a metallic surface? ഏത് റേഡിയേഷനാണ് ഇലക്ട്രോൺ എമിഷന് ഏറ്റവും സൂട്ടബിൾ മെറ്റാലിക് സർഫസിൽ നിന്ന്? ആൻസർ മൈക്രോവേവ്സ്, എക്സ്റേസ്, അൾട്രാവയലറ്റ്, ഇൻഫ്രാറെഡ്. ദ ആൻസർ ഈസ് അൾട്രാവയലറ്റ്. ഈ ഗ്രൂപ്പിലാകട്ടോ. ഗാമാറേ തന്നു കഴിഞ്ഞാൽ ഗാമാറേ ആയിരിക്കും ആൻസർ. കാരണം ഏറ്റവും കൂടുതൽ ഫ്രീക്വൻസി ഉള്ളതാണ് ഇവിടെ ഉദ്ദേശിക്കുന്നത്. See, explanation. Ultraviolet rays are most effective because photoelectric emission effective for photoelectric emission. Ultraviolet rays are most effective for photoelectric emission because they have the highest frequency among the four members given there. When compared to other electromagnetic waves, and hence the most energetic among all of them. അൾട്രാവയലറ്റ്. ഈ ഗ്രൂപ്പിനകത്ത് ഗാമ റേസ് ഉണ്ടെങ്കിൽ ഗാമ റേ ആണ് ഉത്തരം. കാരണം ഗാമ റേക്കാണ് മാക്സിമം ഹയസ്റ്റ് ഫ്രീക്വൻസി. Number 6, photoelectric emission is possible at all frequencies. Is it true or false? We have to say whether the statement is correct or not. Say true or false. A true, B false. The answer is B false ആണ്. കാരണം അതിനൊരു വർക്ക് മെഷർ ഉണ്ട്. ചില പ്രത്യേക ഫ്രീക്വൻസിക്ക് താഴെയുള്ള റേഡിയേഷൻ വീണാൽ എമിഷൻ ഉണ്ടാകത്തില്ല. No, photoelectric emission is possible only if the energy of the incident photon is greater than the work function of the metal. Work function W0 is h nu 0. Hence, the frequency nu of the incident radiation must be greater than the threshold frequency nu 0. Threshold frequency nu 0യിൽ കൂടുതലുള്ള റേഡിയേഷൻ വീണെങ്കിൽ മാത്രമേ ഫോട്ടോ ഇലക്ട്രിക് എമിഷൻ സംഭവിക്കുകയുള്ളൂ. ചില റേഡിയേഷന് അത് മെറ്റൽ വെച്ച് മാറിക്കൊണ്ടിരിക്കും. ചില റേഡിയേഷന് ഈ ത്രെഷോൾഡ് ഫ്രീക്വൻസി കാണില്ല. Number 7, two metals A and B have work functions 4 eV and 10 eV respectively. EV means electron volt. Which metal has higher threshold wavelength? Metal A, answer A. Metal A, metal B, both, neither. The answer is A, metal A. മെറ്റൽ എക്ക് വർക്ക് ഫങ്ഷൻ കുറവാണ്. അതാണ് കാരണം. എക്സ്പ്ലനേഷൻ. അക്കോർഡിംഗ് ടു ദി ഇക്വേഷൻ W0 is h nu 0. Nu 0 is threshold frequency which is equal to hc by lambda 0. Nu 0 is c by lambda 0. C by lambda 0. Lambda 0 is called threshold wavelength. The work function is inversely proportional to the wavelength. So metal A with a lower work function has a higher threshold wavelength. You hear? According to the equation W0 equal to h nu 0 equal to hc by lambda 0. You know nu 0 is c by lambda 0. The work function is inversely proportional to the wavelength. So metal A with a lower work function has a higher threshold wavelength. Number 8. Give the unit work function. Electron volt, joule, hertz, watt. You remember the work function can be expressed either in electron volt or in joule. But in the case of electron, it's a very small particle, very small charge, very small mass. So very small unit of energy should be used, and that unit is electron volt. So the most appropriate answer is electron volt, even if joule is a unit of work function. Answer A. 1 electron volt is the kinetic energy gained by an electron when it is accelerated through a potential of 1 volt. Therefore, 1 eV is 1.602 electronic charge, 1.602 into 10 raised to minus 19 joule. That's the conversion factor. Number 9. What is the frequency of a photon whose energy is 66.3 eV? Electron volt EV. EV എഴുതുമ്പോൾ E small letter, V capital letter. What is the frequency of a photon whose energy is 66.3 eV? Answer 196 into 10 raised to 16 hertz, 1336 into 10 raised to 16 hertz, 1.6 into 10 raised to 16 hertz, 16 into 10 raised to 16 hertz. The answer is C, 1.6 into 10 raised to 16 hertz. The answer is explained as below. Frequency can be calculated as follows. I knew it is not V, it is nu. Nu is E by H. That is nu is 66.3 into 1.6 into 10 raised to minus 19. We convert the energy into joule. By H, 6.63 into 10 raised to minus 34. The answer is nu is equal to 1.6 into 10 raised to 16 hertz. Number 10. Calculate the energy of a photon if wavelength is 6,600 angstroms. Answer A, 30 into 10 raised to minus 19, 3 into 10 raised to minus 19 joule, 300 into 10 raised to minus 19 joule, 3000 into 10 raised to minus 19 joule. The answer is B, 3 into 10 raised to minus 19 joule. The calculation is, given A is 6600 angstrom, we can convert angstrom into meter by multiplying it by 10 raised to minus 10. Energy of photon is hc by lambda. hc by lambda, that is E is 6.6 into 10 raised to minus 34. H we can take as 6.6 or 6.63 or 6.626. For easy calculation, it is better to take the value of H as 6.6 into 10 raised to minus 34 into 3 into 10 raised to 10 by 6600 into 10 raised to minus 10. The terms cancel, we get E is equal to 3 into 10 raised to minus 19 joule. That is all with this first class. Thank you very much.